Hello, this is Susan Poss. I'm going to talk with you today about roots and radicals, and we're going to be talking about square roots and cube roots. So let's begin by talking about square roots. A number is squared when you multiply that number by itself. So for example, if we take 3 and we multiply it by itself, we can also write that as 3 squared. So if an integer is squared, the result is called a perfect square. So when I take that 3 and square it, this 9 is the perfect square. So I have a chart here that lists the first 20 perfect squares. So let's just pick out one and look at it. Here you see the integer 7, and the perfect square is 49. And the way you get from 7 to 49, of course, is you multiply 7 by itself, or 7 squared. Let's look at another one. Here's 15. The integer is 15. If we take 15 and multiply it by itself, we end up with the perfect square, 225. As you work with square roots, it's really nice if you can memorize some of these perfect squares. It helps your work to move a little faster. But of course you have your calculator to help you with that. All right, so what if we do the reverse process? Instead of taking a number and multiplying it by itself to get a perfect square, what if we take the square root? That is taking the process and reversing itself. So we've got some new symbols for that. Let me scroll down so you can see a couple of these symbols. This is called the radical symbol. Looks sort of like a long division, but it's got a little V component out here in front. And the number that sits underneath the radical is called the radicand. So it would sit in this position here underneath the radical. So the expression, we read this, the square root of 64, this is called a radical. So you'll hear people talking about, I've been working on radicals, so this is a radical, the square root of 64, or it's sometimes called a radical expression. So those mean exactly the same thing. And if you have a calculator, you're going to want to look around on your calculator so that you can learn how to take square roots on your calculator. When you take a square root, the calculator is only going to give you the principal or the positive square root, but there is also a negative square root, so you'll be looking at two results here, a positive result and a negative result. And of course, here's the notation that 0 has only one square root, which of course is 0. So we call these the principal square root for the positive one, and we call it the negative square root, of course, for the negative one. And as you advance further along in your math, you will sometimes see this written with both a plus or a minus out in front to indicate that there are two solutions, a positive and a negative solution. So let's scroll down here and try just a few examples. So the square root of 49 is equal to 7. And let me write y. Because 7 multiplied by itself produces the radicand, the number underneath here, of 49. The square root of 121 is 11, and again, because 11 squared is 121. Let's do one that's got a decimal in it. The square root of 0.46 is 0.8, because if you multiply 8/10 by itself, you will get 64 hundredths. And these last two, I want to note, I'm going to skip this one. I want to note this one is a negative square root, so I will get a negative result. You carry that negative sign out in front, and here we have a problem, because if you try to take the square root of a negative number, there is no solution in the set of real numbers. And let me see if I can show you why. Let's say that somebody thought the solution was -6. But if you multiply -6 by itself, you don't get negative 36, you get positive 36. So it turns out that neither of these options, positive or negative, is going to bring you to a negative 36. So for now, we're going to say that this has no solution in the set of real numbers. Later, when we go on into complex numbers, and some of you will learn that further along, you will find that in the set of complex numbers, there is a solution for the square root of negative values. Okay, so let's look at rational versus irrational, because now when we're moving into these square root functions, you're going to have some that are going to come out as rational results and some that are going to come out as irrational results. So I want to talk to you briefly about these two definitions. Rational numbers, this comes from the root word ratio, and these are numbers that can be written as fractions. So here are some examples of rational numbers. 3 over 11, when you convert to its decimal form, you'll see this repeating 2, 7. Negative 4/5 is rational, written as a ratio or fractions. That converts to a terminating decimal. And 1/7, when you convert it to a decimal form, you're going to see a repeating sequence of 6 numbers: 1, 4, 2, 8, 5, 7, 1, 4, 2, 8, 5, 7. So if you can look at the decimal form and see that it either terminates or repeats, then you know that you're working with a rational number. When you move on to irrational numbers, these cannot be written as fractions. And when you look at their decimal form, and I have just a couple here for you, you can see pi. I've written out 6 decimal places. This is a non-repeating, non-terminating decimal, which puts it into the irrational category. And here's why we're talking about this now. So if you look at the square root of 2, you're looking for a number multiplied by itself that produces 2, and you can see it's a non-repeating, non-terminating decimal. So the square root of 2 would be considered an irrational number. Here are a couple more examples. The square root of 45. You see how I've done an approximate notation here because I've rounded it off. And the reason that's true is if you multiply 6.7082 times itself, you'll approximately come back to this 45. Here's another approximation, the square root of 19, another irrational number, and I've rounded this one off to 4 decimal places. So as you work with these, you'll probably be given instructions that tell you something about rounding. It'll say to 2 decimal places or 3 decimal places. You'll just have to pay attention to the rounding notation. All right, so that's a little intro to square roots. Let's talk about cube roots. A number is cubed when it's used as a factor 3 times. So let's say we take the number 3 and now multiply it by itself 3 times. This brings us to a result of 27. So we took the 3 and we cubed it. And of course this 27 that we get is now called a perfect cube. And I have another chart here for you to take a look. The top row is giving you the numbers that are being cubed, and then you see here, I'm sorry, we're taking the number and cubing it, and then these are the perfect cubes that you're seeing. So 4 cubed, the perfect cube is 64. 8 cubed, the perfect cube is 512, and you see that these numbers accelerate very quickly because you're multiplying the base by itself 3 times. So as you would guess, the reverse of cubing is finding a cube root, and the way you denote a cube root is you use that same radical symbol, but now in this position you have what's called an index number. And that index number in this case is 3. Because we're taking a cube root. So the cube root of A, written like this, is equal to some number B, only if you can take B and multiply it by itself 3 times and come up with this result that's under the radical. And one more thing here, we can take cube roots of negative numbers, which we couldn't do for taking square roots. You only have to take square roots of positive numbers. So let me scroll and let's do a few examples here. And the first example that you see is taking the cube root of -1, and that is equal to -1 because, let's go back and think about the definition. If I multiply -1 by itself 3 times, I get the result -1, which is the thing that you see here under the radical. The cube root of 27, that happens to be a perfect cube, is 3. And again, because if you use 3 as a multiplier 3 times, it produces this result, 27. Let's look at the fraction one. If I take the cube root of 27, you'll notice I'm splitting this apart. I'll get 3. And if I take the cube root of 64, I will get 4. So when you take the cube root of this fraction, you end up with the fraction 3/4. Why? Because if you multiply 3/4 by itself 3 times, you will end up back where you started under the radical with 27 over 64. And the last one, I just wanted to remind you that you can take cube roots of negatives, just like we did back here. The cube root of -125 is -5. And again, why is that? Because if you multiply -5 by itself 3 times, you will get -125. So those of you who are working with calculators, you're going to want to look around on your calculator for something that looks like that to let you know that you're working with finding a cube root.